For the next meeting, we are going to talk about sound wave. Sound wave is the energy transfer from vibrating object. It's the energy transfer from the vibrating object. The propagation of sound, how we can hear the sound. First, there is a source of the sound here first, and then the second is the medium, and the third is the receiver here. So the medium, we have three medium: the solid, liquid, and gas. Okay, so remember, sound wave only can travel if there is medium. If there is no medium, so the sound wave cannot travel. Okay, and then according their frequency, the sound can be classified, okay, or can be divided into three range of frequency. The first infrasound, the second audible sound, and the third is ultrasound. The infrasound or infrasonic, if the frequency less than 20 Hertz. And then audible sound, it means the sound that can be heard by the human. It's between 20 Hertz until 20,000 Hertz. And then ultrasound or ultrasonic, if the frequency more than 20,000 Hertz. Okay, the animal that can hear infrasound is kind of the dog, and then the cricket, the rhinoceros, or the animal that can hear the ultrasound, and then the infrasound, and then the ultrasound, the animal that can hear the ultrasound, such as bat, and then dolphin, and then the whale. Okay, so they can hear the ultrasound. Next, same with the wave. The sound wave has characteristic. It has amplitude, okay, and then frequency, and then a sound quality or timbre, and then the speed of sound, of course, this one. Okay, the amplitude. The amplitude describes how loud or quiet a sound appears. So if the amplitude higher, so the sound will louder. If the amplitude is lower, so the sound will quiet. Yeah, and then the next is frequency. Frequency is the measure of high or low a sound is perceived to be, or depending on the frequency of the sound, or we can say the pitch here. Okay, the higher or the lower of sound, we call it as a pitch. And then sound quality, we have timbre, is the musical quality of a tone resulting from the combination of harmonic present at different intensities. The intensities of the sound, okay, the intensity of the sound we measure with decibel meter. The unit is decibel. Okay, and then speed of the sound depends on how quick one particle can transfer its motion to another particle, and the temperature of the medium. So it means a more type of particle, okay, it can transfer the motion faster. So the speed of sound will faster in medium of solid, and then the second liquid, the third is gas, the last is gas. Gas is the slower. And then the temperature of medium. If the temperature increase, so the particle will vibrate faster, right? Temperature increase will vibrate faster. So it means, look, the particle will move quickly, faster. So it means the sound will transfer quickly too. Okay, increase the temperature, the vibration will move faster, so the speed of sound will move faster. The speed of sound same with the wave v equal with wavelength over period, or speed of sound equal with wavelength time frequency. Loudness and pitch. Before, the loudness here depend on the amplitude, and the pitch is depend on the frequency. Okay, the volume of sound is how loud or quiet is it. A sound is louder when the vibrating or bigger. Okay, the pitch describe, and the second, the pitch describe how high or low the sound is. Slow vibration produce a lower pitch sound. Fast vibration produce a higher pitch sound. For the example, this one. Okay, if we compare with this one. Okay. Which one has a slow vibration or lower pitch? This lower pitch, and then fast vibration, this one, so it has higher pitch. Okay, the amplitude. Okay, now for the amplitude, the loudness. Okay, this one and this one. Okay, it has it has a higher amplitude, right? Higher amplitude. This is lower amplitude. So it means this wave, the transverse wave, has louder sound than this one. Okay. Okay, another example or characteristic of sound. Sound can be reflected if the sound crash with the hard object. Okay, if the sound crash with the soft object, the sound will absorb. Okay, the law of the reflection of the sound, the angle of incidence, this one, the angle of incidence is always equal to the angle of refraction, this one. Okay, the reflector sound, the normal sound, and the incident sound are in the same plane. This one in the same plane. The echo is reflection of the sound wave. The echo, this one. Okay, and then the other characteristic of sound is resonance. The resonance is the phenomenon that occur when the frequency of force applied to a system match to the natural frequency of vibration of the system, resulting in the large amplitude of vibration. The resonant instrument, this one, such as guitar, violin. Okay, so for the example, the tuning fork A this one vibrate, and then it will make the tuning for B vibrate too, because tuning from A and B has same frequency. Okay, so it will be resonance. Is 20, and then the time vibration is 4 seconds. This is 20. Okay, and then we can identify the frequency and the period. The frequency, remember, F equal N over T. N is 20, T is 4, so the answer is 5 hertz. And then T equal 1 over F, 1 over 5 equals 0.2 second from the period. So the frequency is correct here, 5 hertz, same. And then look at the waveform here. The amplitude is the maximum distance from the equilibrium position. This is the amplitude, this is the amplitude. So the amplitude is 5. Amplitude is 5. The amplitude is 10. No, so it's not correct. And then the correct statement, okay. Again, the second, the wavelength. So how many waveform here? Okay, one, right? And then 2, and then half. So 2.5 wave, and the distance is 100 centimeter. So we can say the S is 10 centimeter. Lambda or wavelength here, the wavelength equal with the distance where the wave travel over and the number of waves. So 100 over 2.5 equal with 40 centimeter. So this is correct. Okay, now we identify the speed of wave. Speed of wave v equal f times lambda, right? So the f is frequency 5 times lambda. 40 centimeter. 40 centimeter, how many meter? Is 0.4 meter, right? Because the unit of the speed of wave is meter per second. So the answer is meter per second. This one. So A is the correct answer.